Hello guys, I'm back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plain design, and today I'm here with you in another live session. And this is a special live session. Usually I do these sessions on Saturday, but I had some issues on Saturday, and because of that I'm doing this Monday morning here in Brazil. And not only that, this is a special class also because I will share with you how I do to challenge my students in the training program in Process Booster to improve their skills in plain design. So before I start with the content, and I will share here with you a case study, adaptation of a case study, and what are the deliverables that the chemical process engineer must develop and issue to solve or to finish a task in plain design. Let me ask you to subscribe to the channel if you like this content, and if it helps you, share this content with other people, because this way I will be pushed to bring much more content to you. Not only that, for me, I am Brazilian. I am with my Brazilian soccer t-shirt, and it is not Brazil game. There is no Brazil game today, but it is very, very important to me to know where are you from, because this way I can know how far a chemical process engineer, a Brazilian chemical process engineer can reach people in the world. So this is it. And to start with, let me be a little bit smaller. I had other advices to give you, but I need to take notes because I forgot about them. So let me be a little bit smaller to share with you what we'll see today. Just a moment. If you have questions, I will answer them in the end of this live session. And you can add your questions in the chat or in the comments. If you are live with me, feel free to add your questions in the chat. But if you are looking for the reprise or the record of this live session, let your questions in the comments, because I always consider the questions that I receive to do more content to you. So okay, it's okay here. Okay. So some of you know that I have a training mentoring program to help you people how to use Aspen Hysys on plain design, and this mentoring program is called In Process Booster Mentoring. And recently I added a new model to the training program in order to push people to apply what is learned during this training program. So the training program is split in Aspen simulation, in pipe instrumentation diagram, and also in process data sheet for equipment, instrumentation, etc. And because of that, what I have seen is that many courses focus only in Aspen Hysys, and it is not my objective to teach people only Aspen Hysys. So the Aspen Hysys is only the small part of the project. It's from there that you get all not all the answers, but almost all the answers that you need to develop the others engineering drawings. And in this test your mind, what I do is show how to use the Aspen Hysys and how it affects the deliverables that you must do to finish a plain design. And these references if for younger people you are in touch with Mortal Kombat, I think that is 11 or XI. But this here you have a picture screen of the original one, the first one with the digitalized people. Let me just a moment. Let me add this. I have seen that we already have people in the chat. So Islam from Tulsa will welcome. How much a process engineer could potentially earn in your point of view? I will answer some questions in the end of this live session. Assad, and hi, I am from Iraq. Nice to have you here. Al Rukabi, nice, very nice. Drop your Insta account also. All my social media is available in my website, jeffersoncosta.com. So if you go there, you will find how to connect with me in LinkedIn, links to my YouTube channel, Instagram, Facebook fan page also, and how to join my Telegram channel in process. And I really recommend you to go there because it is there that I share all the news. And also you can, in my website, you can subscribe to my newsletter, and in the newsletter you will receive some information also. So guys, okay, and I was talking about the Mortal Kombat. So this is a print screen, a reference from the Mortal Kombat, and this is the wood challenge, and it is the easiest one. Once we go through the game, we have more tough conquests or to surpass. So it is what we will see here right now. So the case study, what it is adaptation for a class from a colleague from Brazil, from Nicolas Pages. He is a professor that teaches DWC in Brazil in Portuguese, and I got his example to build this challenge, and I have a purpose for that, and you will know in the near future. But for now, how looks like test your mind in the in-process booster mentoring program? You have a case study. So in this case study, what we have here is 1,000 kilograms per hour of water ethanol stream with 50% of ethanol at sea level pressure and 20 Celsius degree is heated to 65 Celsius in an electrical heater. The warmed stream passes through a vessel V101 and it is pumped to another process. The Li101 must be kept at 25% minimum to avoid pump cavitation. So this is the big view. Every time that you start a project, most often we have something that is called kickoff meeting. Kickoff meeting is a meeting to address the current conditions and what are the expectations that is related to the project. So I will start a new polypropylene plant. I will revamp a nitrogen plant. I need to do some kind of modification in a hydrogen unit. So the best practice is that we have a kickoff meeting first to officialize that the project now is counting their time, its time, because every a project is different from operations. We have a well-defined, or we should have at least a well-defined scope, schedule, and cost. So the kickoff meeting is to let everyone in the project aware of these three topics or these three themes in a project. So here I give in to you in the first paragraph what is the current status, and it will be important and you will know why. And now we have the challenge, or we have the problem that we have solved in the field. because we do plan design to solve problems. I always say that we start from the problem and we identify what are our resource or raw material, and between the raw material and the problem or the product specification, we need to design a process able to achieve that. So this is the way that happens in the real life. Just to give you an example, currently I am working I working in a process that we having a very pressure drop in our meter system, and my gas is saturated with water, and to sell that gas or to process that gas, I need to remove the water from the hydrocarbon stream. So what drives me to start a process simulation is to solve the problem with the hydration, with the humidity in the natural gas. So I went to the process simulation, I changed the conditions, and I need to define what would be the minimum pressure drop on that system to work properly. But not only that, the process simulation by itself doesn't solve anything. You need to do changes in the real life, or you need to develop documentation that are able to buy equipments, control valves, PSVs to the real life. So that's why it's important to the chemical process engineer or to the chemical process engineer that is interested in working on plant design to know about that. So our problem here is that your boss or your company asks you to verify if it is possible to withdraw a gas stream with 55% ethanol from V101. Besides that, you need to develop a basic set of engineering documentation showing the changes needed in the installation. You have the problem, you need to identify the current conditions of the problem, you need to understand what kind of solution you must suggest to solve the problem, and to complete the package, you need to develop a set of engineering deliverables. And in this case, and it is the minimum, of course, that depending on the size of the project, depending on the step of the project, there are many more deliverables that must be filled or developed during the plan design. But to start here, we need to develop, or the members of my training program must develop, the process simulation file in Aspen Hysys V11 or lower version. And this item 1 is just because the software used in the training program is the Aspen Hysys. You will use this process simulation, the process simulator that is available to you. And it can be the DWC that's free for download and use. It can be the KenCAD, it can be the Promax, and Unison Design, Aspen Plus. There are a lot of process simulator software, commercial ones in the market, and there is some free one like DWC. So you will use what is available to you. I receive a question these days asking me what would be the best software to do pipe sizing, if I'm not wrong. The best software the best software for you is the one that is available. If you don't have any simulation software to use, you need to build your own spreadsheet, and what happens in the companies is that you will use what is available there. Okay. Another thing that is very, very important, and I suggest my students to do that, is start doing the process flow diagram. Don't go directly to the process simulation. First of all, you need to build the process flow diagram, because this way it will give you a better understanding what is happening. And of course, when we are talking about plan design, everything is developed from the piping and instrumentation diagram. In the early stages, it don't need to be too much detailed, but a pipe instrumentation diagram helps you to identify what are the disciplines that are related to that kind of modification. If we have more scope of instrumentation engineering, if we will have scope of mechanical engineering, automation engineering, and etc. So those disciplines will use the pipe instrumentation diagram to build their work. They will not use the process flow diagram, and they will not use your process simulation. Okay, and of course that if you need to add some kind of equipment, control valves, PSVs, fittings, we need to develop a data sheet for quotation. And I talk about quotation because, as I told you, one of the objectives or one of the steps of a project is that we have a cost. So in preliminary stages, we deal a lot with paper, but we are able, with the paper that we develop, we are able to do some kind of estimation. And imagine that if for doing this modification in the plant, I need to expend $1 million to do this kind of modification in the process. So if my product will not earn this amount of money, it doesn't make sense to do this kind of modification. Let's keep the process as it is, and everyone will be happy. So every time that we are talking about plant design, we have some kind of economical evaluation, and we start with the preliminary or the conceptual design of the idea. And once we have more information, the management are able to do better choices and allow you to spend more hours developing the engineering documentation and etc. Until or up to installing everything in the field and starting the operation. But not only that, another thing that is very, very important is you will do your process simulation, and from there you will get the heat and material balance. You will do the process flow diagram that is a graphical representation of your heat and material balance. You need to do the piping instrumentation diagram, data sheet, and it is very, very important that you have a process engineering report. And the name used to identify that will change from company to company. When I was in my previous company, it was named EDM, Engineering Design Memorandum. So what this document says is you summarize everything that must be done to install the solution in that project. So in many cases, we add the local data, we add the process description, we add the power consumption when we have some kind of electrical equipment. We had considerations related with the basis design for the project and etc. So this is the minimum set of documents that you must develop. And if you go to company's website and look for process engineering position, you will see that it matches with our required data. So this is what I work with my students and the members of my training program in Process Booster Mentoring. But not only that, to help them to develop this challenge, to win this challenge, there are some kind of advices, and the process flow diagram must be issued in PDF and includes stamp number, revision, fields, and approval. And that's it is this way because when we are talking about engineering documents, we are talking about controlled documents, and the controlled documents is only controlled if you have a stamp identifying who did that, who verified, who approved it, the number. Each document in the plan design is like your ID. They have specific identifications that depends on the procedures that the company uses to identify them. And here, something important that is to point or to highlight is that when you're having an existing process and you need to do some kind of modification in an existing process, a good practice is that you identify what is new to the existing process in some way. And in this process flow diagram, I recommend to use red markup. So you will see how to do that. I will use Microsoft Visio to show you how you can build this very fast. But you can use also, and it's very common when I using the AutoCAD software, is to use bubbles or clouds to circumscribe what's new to the process. I will not show you there today. And I think that I recommend people also to do when we are, in this case, I am already giving a hint that a control valve will be needed, but we discuss what is the location that this control valve should be installed. So you can do the preliminary CV sizing in the Aspen Hysys, but I do not recommend to do that. What I recommend you is to use a software from a supplier, because that will save you time, because from the supplier software I can get the size of the control valve, so I can do more information to my preliminary pipe instrumentation diagram. And another thing, as they are members of my training program, they can compile all of these and send me by email, because it's very common that when I'm doing this right now. I just finished a work where I did the documentation, I compiled that and sent for approval. So this is the way that it's happening. And if we have any kind of question, I send the question by email, because this way we have a history of what was asked, what was answered. And this way, if we have any kind of inconsistencies or misunderstanding, it is easier to verify what was defined during this process. So that's this, as I told you, test your mind in my training program is to simulate what is the real life. And now it is exclusive to my members of my training program. I recommend what are the classes or what are the models that should be watched to help with the understanding what is asked for. So for this specific case study, the models 1 and 2 and 3 and 4 are recommended to be watched, because you will not start in doing a work if you don't know what you need to do. And in the pipe instrumentation diagram course, there are some classes that I also recommend to watch. And there is the process datasheet course, and with the control valve datasheet and the templates, all of them are there. And all the clarification, as I told you, must be done by email. So this is a big picture. And I think that yesterday I received a question from Poland. I think that is Stan from Poland asked me how to find good references to simulate for simulation or something like that. I will answer better in an audio in my Telegram training process. It's hard to find this kind of tests in the internet, because it's not the drive of the books to to work or to operate on this way. You will find this or on the job or in my contents. Probably after this, many people will drive this way, but it is what I do. Okay, so now let's go to the set. Let's go. I will discuss with you in this live session the two first points. Okay, just before I forget about that, I will not cover the point 3, 4, 5. It is for in-process booster members. I will discuss with you how to do the process simulation from this case study, and how to start a process flow diagram, a simplified process flow diagram in the Microsoft Visio. And I will suggest you also another source to do your drawing, and that is totally free. I don't use, but if you don't have the Microsoft Visio, or if you don't have the AutoCAD, it's a good alternative. So let me be a little bit bigger again, and I will take a look in the chat before we go to the developing the documentation. Okay, so let me see what we have here. Hash, which software should I learn if I want to build my career in process engineering fields? Okay, I will start answering some questions. Okay, so how much a process engineer could potentially earn? So Assad, it depends on your country. If you live in US, it's totally different from people that lives in Brazil. That's totally different from people that lives in India. So what I can suggest you to take a look is exploresalary.com. I think that is you can Google that and find, and there from region and from country you can verify what are the average earning and the minimum, the maximum, and build your decision. Let's see here. Drop your Instagram account. So my Instagram account you can find from my web page, jeffersoncosta.com. In the end of this live session, I show you how is it. And another thing I have available in my Instagram is available in the description of this video also. In my website, you'll find a free training with more than 7 hours of chemical process engineering plan design to help you get familiar with the roles and responsibilities of the chemical process engineer. Okay, so if you want to know more, feel free to subscribe and get for free this course. I have another question. How can I learn Hysys from Aspen Hysys registered version? It's very easy. You go to the Aspen Tech website and verify how to do that. So aspentech.com, you have the courses, and they will give you they will lead you how to do this. Okay, I think that the Aspen Tech courses, it's around it's around $1,000 or something like that. Hash, which software should I learn if I want to build career in process engineering fields? So I have a video here in my YouTube channel talking about the most the software that I use most. So Hash, take a look on that. But I can say that at least one process simulation software, it's good to learn, because it will save you some time to use others, although they are not the same. But if you understand what is the step by step, it will help you a lot. Okay, but not only that, softwares are important, but you need, in my point of view, you need to know the working process, and it is what you show what you find in my YouTube channel and in all my content is the working process to work with plan design, the chemical process engineers. Okay, I have another question here. How many hours should we spend on your course, and how long to see good improvement? That's a nice question. I believe if the person has the commitment to do that and time to do that in 2 months, it's possible to know or to get familiar and start doing this kind of challenge, to solve this kind of challenge. It's totally possible in 2 months to do this, okay? As I told you, this is the easy mode, but my training program is a 12-month subscription plan, so you have enough time to learn everything from there. How to find Aspen Hysys? Very easy. Top music, Google that, and you will find. I couldn't download it. Please give you some device. I don't share any kind of links for download Aspen Hysys. Okay, there is especially in social media. If you want to download Aspen Hysys, you can type on YouTube. There are some YouTube channels that talk about that, or you can go to some Facebook groups and search there. What I can tell you is that exists cracked version of Aspen Hysys, as exists people selling drugs, and if you want to buy drugs, you should not go to LinkedIn, you should not go to YouTube and ask, oh, let me know where you can buy drugs. It's not the way that things happens. So it's just a matter of good sense. So this is it. Enough talking. Let's go to the Aspen Hysys, not the Aspen Hysys. Let's go to the process flow diagram. Just a minute, please. So let me be a little bit smaller again. So now I will share with you how I use the Microsoft Visio to do this representation of this process. As I told you, in my point of view, it's very important that you start from the process flow diagram. And I am not here to give you a complete class about the Microsoft Visio. There are a lot of features that this software has that I don't know how to use yet. But to start with, if you get in touch with that, I think that something will be useful here. So the first part is that we must understand what are the big view of the process. So we have seen from the beginning that we have a stream, a water ethanol stream, and the composition. We know the level and pressure. We know that it's heated and that it's go to a vessel, and after that it's pumped to another process. So let's start with the representation of this process description. The engineering drawings, we usually it's very common that we start that with a flag and we end that with a flag. So the flag, depending on the case, it's our battery limit. And I have a specific video to talk about battery limits. I will not talk about that right now. You can battery limits and tie-in points. You can see that detailed class about that. So let's start with the Microsoft Visio. You have let me, yeah. We have a specific part here in the software that address to you the most common representation of process for process engineering. So we have here process annotation, we have equipment pumps, so you already have all the symbols that are available in the software. We have general equipment, vessels, a lot of examples of vessel, instrumentation, pipelines, we have valves and fittings, heat exchangers, and here I added also basic shapes that we are able to draw our own. We are able to draw one equipment that is not available in the Microsoft Visio and save that as a equipment. So as I told you, we start with a flag in our engineering draw in our process flow diagram. And just to remind you, we need to have a stamp in our drawing, because if you don't have a stamp, it is not an engineering drawing. And my students have access to this template. So the process annotation, I will start with this flag here. And in the Microsoft Visio, they have an option to you link one page with another. I will not use that. And we need to identify from where the stream is coming from. This is, and remember that I'm talking about process flow diagram. I'm not talking about pipe instrumentation diagram. So we will do a simplified drawing here. So what I have is I will identify it as the from storage. So I have a liquid stream going from the storage, and it is my main line. So the main line, I will use a thicker line to help people that will get in touch with this drawing to know what is the main process of my representation. And we have that this stream is heated. So I need to add equipment representing the heating. I'll use this one. Right now, I am not so worried about what I mean by that. I'm not worried if it's in fact represents electrical heat or not, okay? But I will add that. What happens in real life is that your company already have a sheet of symbols. So you will use the symbols that is available in your company procedures, okay? In this case, we are using what is available in the Microsoft Visio data bank. And after the heat exchanger, after the heat exchanger, we have the vessel, and the liquid is pumped to the process. So if I have a vessel, what's happening here, depending on the conditions, I will have the disengagement of gases from the liquid. So the gas goes out from the top, and the liquid is from the bottom. So I will add to my process the liquid stream, and here you can see, let me add the pump and do some comments. Okay, and it says that the mixture is pumped to another process. So to finish my drawing, I will add another flag. You can see that is just click and drop, okay? And this is, it has this big view here. And so I have a a mixer stream, it is heated, it goes to a vessel separator, and it is pumped to another process. So let's just identify two process. So here it is what is existing. It's the way that it is today. It doesn't talk about having a gas phase from the separator. It's the problem description, the case study don't talk about that. But our boss wants us to know if it's possible to withdraw a gas stream from the separator. So we will assume that currently there is any kind of gas line in the vessel separator, but there is some kind of nozzles, and we will add the nozzles to our process flow diagram. Okay, so just before doing that, it is asked to do a simplified process flow diagram. The process flow diagram, there are many ways to do that, and we add the main components, the main equipment of the process, and we need to identify the streams in order that it's easier to you go to a table and verify that, for instance, stream 1 has the following conditions, the stream 2 has the following conditions. And what I do, instead of doing this kind of process flow diagram, I will do a simplified one that I named that is add some information directly in the process flow diagram, because this drawing is not complex. We have space for that. So in this case, I will add annotation. Let me see here. So I know that I have water and 50%, and I will consider that percent mole. I have ethanol, 50% mole. Another information that I have is pressure and temperature. So temperature is 20 Celsius and pressure is sea level pressure. So you know that sea level pressure is 1 atm, and the units that you should add to your process flow diagram depends on the units of the customer wants to, or the units that you have in the field. For instance, if your plant, all the manometers in your plant is informing the reading, the measurement in PSI or PSIG, you will not use kilograms per centimeter square in your process simulation. You use the same kind of measurement. It's the same for temperature. If your all temperature devices informs the temperature in Fahrenheit, you will use Fahrenheit in your process simulation, not Celsius degree. So in this case, let's use the 1 atm just to let our life easier. ATM is not must use it. The main units that I have seen is bar G or bar and bar G, that's manometric meter measurement, and the PSIG. So this is the main one, but in some cases, because the international standards, the equipment informs the pressure in kilopascal, but in the field I have never seen kilopascal measurement. Okay, so this process now tells me that the stream is heated to 65 Celsius. So I will do a Ctrl C, Ctrl V, and now I will add a new information. The composition, the general composition will change? Not. So because of that, I will remove, and I will let information that is important to my process. We don't want to adds to repeat information that's not necessary. So what I know here is that it is 65 Celsius degree, and it doesn't talk anything about pressure. So for this moment, I will consider that the pressure drop from the equipment is 0, and you will understand why. For a first approximation, we will consider this one. We are considering that we are in the conceptual design of this modification, so it is all preliminary information. But in real life, most often all equipments have some kind of pressure drop. Okay, so and I have no information about the pressure or the head of the pump, and it is for me it's not so important. But there is information that talks to us is that the vessel must be kept at a minimum of 25 level. So I will add here an instrument to indicate the level measurement. Let's see here. So LI. I will not do the connections right now, okay, guys, just to save time. But there is a connection between the LI and the vessel. So for now, it is it. Now let's start with the modification. What I want to have is a line with withdraw the stream here. And as I told you, let's consider that it is a totally new line. So it's not the main purpose of this process is not to get this gas. It's a secondary process. So in this way, what I will do is a thinner line than the main process, and this I will identify as red, because this way a person that gets this drawing will know that it is new to the process. Okay, so for what is this, and I need to add a flag identifying to where it's going. If it is a pipeline that goes to atmosphere, for instance, if it was a vessel open to atmosphere, I could add here a notation telling to safe location or to atmosphere. But as it will go to another process, I need to add a flag. So let's add another notation. And here I will consider a new process. So I will get here. I don't know how much I will be available for me yet, but I will use this as preliminary to help me to update after I do the process simulation. So this is the basics in my drawing. So I start with the process flow diagram, and now I will build this in the process simulation software. And why I don't do it directly in the process simulation software, because in my point of view, you get a better understanding of the process, and you need to develop a process engineering documentation, and you will not do a print screen and copy in your engineering drawing, because that is not a very nice way to do that. So let's consider this and let me save. Okay, so now let's go to the process simulation software. Let me see if you have any questions up to this point. Okay. Let me take a look in the chat. Hello, I am we have this Sai. I am working as internal process engineer. How are you? I'm doing fine. I always like your content. Thanks, Viraj. Thanks a lot. I was learning, exploring every day. Totally did some dynamic scenes in the WC. Good luck for you. The WC is very nice software, and now you have the dynamics available on that. Please make, I have a request here. Sumanth, please make some videos on how to read and make P&ID. I would be grateful if you suggest me some books for that. Sumanth, as in the beginning of this masterclass, I told about my free training, and in this free training you have a video. I think that is 45 minutes video talking about what is the main topics to read a pipe instrumentation diagram. So subscribe to this free training for free, and you'll find the link in the description of this video. Okay, so it may help you. So okay, now let's go to the Aspen Hysys. Let me be a little bit smaller again. So guys, I will start the process simulation here with you from the components or from the property environment, and I'll tell you why I'm doing that. In many cases, I use the Peng-Hobson property package to do my process simulation, because they are almost most of the time they are related to hydrocarbons streams. But in this case, what we have is water, and we have ethanol. So a concern to start a process simulation is to choose the correct fluid package. So what we'll do right now is, let's go to fluid package, and let's suppose that I want to use the Peng-Hobson to this specific process simulation. If I go here and tap on Peng-Hobson, the Aspen Hysys will give me an alert telling me that the ethanol is not recommended to be used with Peng-Hobson. So how can I solve this kind of issue? You have in the Aspen Hysys the method assistant, and if you go there, you open the helper of the Aspen Hysys, and you are able to verify what fluid package address better for the kind of process you are developing. So in this case, it's not a oil and gas processing, it's not a refining, it's not electrolyte environment, and none of them. I will consider that what is near to this process that I'm doing is a chemical. So if I click on chemical, I have options here, and you need to read the description to verify what fits to your process. So in this case, low pressure, then 10 bar, I can consider this fluid package here. So I will use the Uniquac. If you click on here, there will be a set of description, and this is a good way to you get familiar with the fluid package, the applicability, and etc. So I can close this one, and I will choose the Uniquac. You can see that I don't have any kind of other warning, and I proceed to process simulation. So I like to have my model palette at my right side. I always get some space to my process simulation, and now I can start building my process simulation in the process simulator software. So I will use as reference my PFD, and this way it will be much faster. So let's start. I can add the heater, and to I suppose that you already know that, but you click on that, hold, and bring it to your process simulation, two clicks, and I can add my streams directly in the equipment. So let's tell this as from storage. And here I recommend you to add the same as possible, the same nomenclature that you use in the process flow diagram, you should use in your Aspen Hysys simulation, because it will be easy to you identify the components, properties, the characteristics of the companies with your drawing and transfer that kind of data. And when we are talking about heater, we always have a source of, we have, let me, so we have two kinds of streams in Aspen Hysys. We have material streams and we have energy stream. And you can see them here. So the blue one is material stream, the red one is energy stream. Not all equipment requires an energy stream, but all equipment will require a material stream. Okay, so when it is light blue, it's undefined, and when it is light red, it seems to be red or not, but when it's light, it is undefined. And I have if I click two tabs, I access the menu, and if I go to composition, I like to, when I have a stream already defined, I prefer to start with the composition, and after that I go to the conditions. Okay, so in this case I will add the composition, and it is mole fraction, but if instead of being mole fraction, it's mass fraction, or if I have the amount of flow of each one, I can change in the composition basis. And on something that you must be aware is that the Aspen Hysys will always adjust the mole fraction in a way that the sum is 1. So if you are filling your process simulation your stream, and let's suppose that I type here, I was typing, and instead of adding 0.5, I add 0.05. If I do OK, the Aspen Hysys will adjust that to compensate, and that can lead some errors to your process simulation. So it's important when you are filling the composition that you get aware of that. So I will fix that. So this way, now it's okay. And now the conditions are that I have 20 Celsius degree. And here I have some ways to proceed with my process simulation. I can keep the basic international standards units here. And when I type 1, I want 1 ATM. So here it's okay. But I can change the unit sets. So if I go to unit sets, I can choose and customize my sets of units. I will not talk about that right now, but I believe that I have a video in my YouTube that talks about that. And the mass flow is 1000 kilometers per hour or 1 ton per hour. So this way we have everything green. It means that it converted, and now we have a dark blue stream, and now everything's okay. And here in the heater, I have two informations from my case study. The first information is that I hit to 65 Celsius degree. But it doesn't tell me about the pressure, the pressure downstream of the equipment. I can, as I told you, we will consider that the pressure drop will be 0. But I have two ways to add that information to the process simulation. The first one is, as it's 0, I will repeat here the same pressure at the discharge of the equipment. So this way, what will happen? The Aspen Hysys will calculate the pressure drop through the equipment. Or I can use the pressure drop directly in the equipment. I will not do that because if you can see that now this information is in black. Every time that you have black information, black values, it means that it is calculated by the Aspen Hysys. I cannot change that. And if I add the pressure drop here as 0, my discharge of the equipment or the outlet of the equipment will be fixed on 1 atm, and I don't want to do that because I will tell you why. So after that, I have a vessel, and to the Aspen Hysys, we always ask you for a vapor stream, and it doesn't matter if based on the current conditions the stream is not vaporizing. And a liquid stream, and it doesn't matter if you are dealing with vapor and the vapor is not condensing. So you need to convert this equipment, you always need to have these two lines. And the vapor will be always in the top and the liquid will be always in the bottom. And I can add some kind of energy if I have some kind of heater or if I have a heat tracing, but it's not the case. So in this case, here I have completed my process simulation. Right now, I will not add the pump because it's not the main concern of this process simulation, the pump. I need to evaluate if it's possible to have a stream with 65% of ethanol in the vapor phase. There are some ways to do that, but first I would like to show you instead of changing, I can do this changing. Use the worksheet. When I open the worksheet, every streams that connected to my equipment will be shown at the same place. And if I do changes here, I can verify, or I can do changes in one stream and verify, click on there in the other one and verify. But I like to add, when I evaluating some changes, I like to add the show table, because this way I can verify if I do some kind of changes here, what happens here. It's better for me. I have a better understanding what's happening. But if you want to see only the temperature and pressure, you have another option. If you go to flow sheet modify, you can add the pressure, the temperature, and you can add the pressure to your process simulation. So it will add information for all streams, and depending on the size of your process simulation, it will be very, very big. It can be very, very confusing, okay? So usually I don't use that. I prefer to use the show table for my specific streams that I verify. So let's add here I'm not interested in molar flow. I'm not working with molar flow. I'm working with mass flow. So let's add the mass flow to our process. And I will do the same in the liquids just to identify what's happening in my process simulation. So based on the current conditions, what I can see is that the liquid is not vaporizing, it is full liquid. And another thing that I can add here, I will not add in the bottom, but I will add in the top, is the composition of the stream. So I want the mole fraction. So here, although I don't have a mass flow, I don't have any flow here through the vapor phase, you can see that the Aspen Hysys do some calculations. So don't worry about that. There is no flow, there is no composition here at the vapor phase. Okay, so to verify if I can get the 55% small here at the top, I can do a try error. So I can change the pressure here manually, or I can do the adjusted. I will do this only one time so you see, and I will use the adjusted, okay? Because it's the... So when I change to 0.5 atm, you can see that I have some kind of flow here in the top, and I have in the bottle, and the flow decreases. So probably it is not the pressure that I want to. So to solve that and solve that faster, what I will do, I will add the adjust, and I will let the Aspen Hysys do calculation for me in a much faster way. And when I add adjusted to the process simulation, I always start with the target because for me it's better for understand. So the target is the place where I want to have the adjusted it's where I want the results. So the results that I want is the 0.65 molar fraction at the VAP. So I will select the variable, I will select the VAP, and I will select the master component flow, the master component mole fraction, and I will select ethanol, so that it is what I want to. And how can I vaporize this liquid? I can vaporize this liquid in two ways. The first way is if I keep the pressure constant, if I increase the temperature, I will reach the boiling point, and I will start vaporizing the stream. Or I can, considering the temperature fixed or constant, I can depressurize or reduce the pressure and verify if I reach the boiling point of the stream. So these are the two ways that I can vaporize. Why I will not consider heating this stream? I will not consider heating this stream because I will suppose I will use as a basis, or I will use as a I will assume that the heat exchanger already doesn't have the enough power. But if I increase the temperature, also I need to verify the internals of my pump. So I will not change anything in the temperature, and what I will change is in the pressure. So this way, what I need to do is select the warm stream and the pressure, and that's why I didn't fix the pressure drop in the equipment, because if I did that, it would be fixed and I would not be able to change the pressure to see how is the behavior of the composition. And to finish that, I need to add my specified target value. So this is the result that I want to, and it is related to the tagged variable. So it's 0.55. once I have some parameters here that I can change the methods, I can add limits for minimum, for maximum, and here I will just add 100, and I need to start click on start to be able to start the operation. So it's already solved, and you can see that to have a vapor stream with 50, almost 55, it depends on the tolerance. Okay, I will not change the tolerance, it's okay for me. If I round it to two decimal, it will be 65. I can have the stream. Now I have some considerations here. You can see that in terms of the process, for sure that we are talking about vacuum, because I am working in a pressure below the atmosphere, and the atmosphere in this case is absolute pressure. I am below the atmosphere, it's in vacuum. So I need some kind of, I will probably have a blower here to do a suction from my process in order to reach this amount of pressure, or to control the system at this pressure. And to be able to control this vessel at this pressure, I have some option here. One is to have a blower with a pressure control, to control the speed of the blower, to keep the pressure inside this equipment as specified. And another one is to have a control valve and consider that the blower, not consider the blower in my process simulation. And it is important to the process engineer understand what is the right location to add the reference for pressure controller. So we have, although I added here the pressure of the stream, in fact, what I want to control is the vapor phase of my vessel. And I will not transmit this pressure to the pipeline, because it's not the correct way. So returning to the process flow diagram, what will happen in this case? I need to have an instrument here to give me the pressure of the vessel, and I will consider that it's a PIT, a pressure indicated transmitter, and this pressure indicated transmitter will send a signal to a controller. Okay, and forget about the blower. What I will consider is the adding a control valve here at the inlet of the vessel, because I will have the 1 ATM here. I will not vaporize anything in my heat exchanger. I will not change anything in the heat exchanger. And to break the pressure, to have the 0.5 ATM around that, that will be my control valve. So my control valve is new to the process, so let's set that on red. My instrumentation is red also, and I will not get into the details about this drawing, but I need, let me see if I find here and I show you. I don't have it here right now. Okay. I'll consider this one. So what will happen here in general? what will happen here? My PIT will get the pressure at the vapor phase of the vessel. It will send a signal to my controller. So this is it will be my PIC, and it should be in the control room, or I can add here a mechanical device, a PCV, to do the same, but let's suppose that it's fully automated. And the PIC will send a signal to my control valve in order to open more, to open more, to close more, to have the pressure controlled. And this will be my basic loop and my preliminary suggestion to my boss. So this is what I would like to have from my students. And here, now that I have the process simulation done, I can update the information. The temperature will be the same because I'm not changing in the information of temperature. In the pressure, let me just see. The correct way is I will consider one-to-one, okay, but it's not one-to-one. It's just to give you a reference. I don't want to do conversions right now. So let me save. And here, with this, I had shown to you how to start doing plan design, because this is the way that happens in the real life. Okay, guys, I expend much more time than I expected to do, and sorry for that. But if you have questions, if you like it, let me know, because I will prepare myself to start my working day here in Brazil. Right now, it's 20 a.m. and 9 a.m. I need to start my working day. So, Mohammed, hi, so can you please put the camera video in any corner? Mohammed, I have a deal with you. If guys, all my videos is available for you for free, okay? In my YouTube channel, I have no plan to remove it from that. But if we reach today, Monday 29th March, if you reach 50 likes in this video, I will let available the PDF with the case study available in the Telegram channel in process, okay? So this way you don't need to worry about my camera. And I will let also available the PDF, the process flow diagram PDF format, in PDF format. Okay, guys, so this is it. Very nice to have you here with me. I had many questions during this live session. It was very nice. And if you don't have any question, it's time me to go. And so I don't have any question. Nice to have you here. Oh. Thanks, Akshay. Thanks, Akshay. Thanks a lot for being here and sharing your time with me. So, guys, this is it. I hope you like it, and I'll see you soon in the next video. I have a goal of reaching 100,000 chemical process engineers in my YouTube channel. So, if you liked this video, please, I invite you to share, to like, to comment. And if I didn't answer your question, let in the comments that I will do my best to answer that as soon as possible. I will consider that actually. I already have a overview for compressors, right? You can see in my videos that there is the compressors fundamentals, if I'm not wrong. You can see an overview of compressors and the chemical process engineering. But I will bring more information about compressors in the near future and of course in the training program. So bye guys.